All right. Hello, students. It is 1:35 on Monday, the 6th of October, 2025, which means that you are in class, and today is actually the 11th of October, 2025. I have already spoken to you about regression analysis. I've shown you the slides. We've talked about what regression analysis looks like and what it does. Now, what I want you to do is I want you to go to scope. I want you to choose your own metric, and you're going to be running a simple linear regression analysis using a metric that you have chosen. I am choosing recognition memory because it was something that we spoke about in Friday's class. You need to choose something else. However, I can show you how to do this. So this is scope. Let me show you actually how to get here. If you just Google scope South Carolina, because it's hosted by the South Carolina University or the University of South Carolina, we click on here. This is the front page. We're going to do a search. We want to download all. We want the words. And then you need to choose whatever frequency, sorry, not whatever metric you want to choose. As I said, I'm going to choose recognition memory, which is something we talked about in class. You need to choose something else. If you need help with that, you can speak to me now. So I'm going to download that. The other file I need is this sublex CMU file, which is what we did in class. Take the first one because that's the CSV. In fact, I will just delete this so there's no confusion. So take this sublex CMU and hopefully this will load. While that is doing that, welcome to R. This is R Studio. You will find R Studio in the applications folder, in one of the applications folders. Apparently there's more than one. The first thing that we do with RStudio is we need to set our working directory. Because you're downloading these files, they'll download to your downloads folder. So I recommend just going to the downloads folder. Okay. And what are the names of these files? What we need is we'll call our first data set sublex read.csv. Underscore CMU dot CSV, comma. I need to set the strings as factors equals false. And I have missed something. Boom. All right, like any programming language, R is pretty finicky. We need to be a little bit careful with it. Did that work? I am obviously missing something. What am I missing? Strings. There it is. Oops. Okay, sublex. We now have the sublex. That's the data set that we made in class last week. Let's take a look at it. I have the word, the frequency count, and then the phonemes. Where was I? Untitled 6. Nope. Untitled 7. Okay, so that's the first one. The next one should be downloaded by now. It takes a little while. The word search. So I'm going to save myself a little bit of time here by cutting and pasting the name. Okay, so second one, we'll call this memory, because that's the memory data set. Should be fine. Okay, so now we have the memory data set, we have the sublex data set. Now, memory data set looks like this. We have the word, the recognition memory, and then X for some reason. So the word compete got a accuracy of 36.66%. Okay, so we have our two data sets. Now we need to combine them. Let me just double check. So here we have word in lowercase. Here we have word. All right. Word in uppercase. Okay. So we need to clean up these data sets. Sublex, hashtag word in lowercase. I'm going to need a different package. I've asked the IT department to install some packages on the computers. The first one we're going to be using for this course is dplayer. Dplayer it's a data cleanup package. It just makes the syntax of things a little bit more simple because you probably won't be using R all that much. Trims, make sure everything's lowercase. Okay, so just making sure that the sublex is lowercase, making sure that the memory data set is also going to be lowercase. Remember that word is capitalized in the other one. Okay. Unexpected symbol. Where's my unexpected symbol? Didn't close mine. Okay. And now need to clean up the memory data set. I have this code, which I'd already written out to make things a bit easier for myself. Word recognition memory. What is your problem? Word recognition memory, word recognition memory, word search, word recognition memory. Memory, word search. Oh, yeah. Still, did I not activate you? Okay. And now we're going to be combining these data sets using the merge function. Just make sure that my names are right. Filter is NA. Okay, so this combines the two data sets into one, but you note that we have all these NA values for recognition memory. So we're going to use this filter. We're going to get rid of all of those. And then our combined data set now has the word, the frequency, the morpheme, the phonemes, and then the recognition memory score. And note here that we're down to less than 5,000 samples, all right? So the limitation here is the recognition memory data set, and now we're dealing with a much smaller data set. First thing first, what should we do? Let's plot. Let's take a look at the relationship between recognition memory and frequency, not log frequency, because we got rid of that. All right. Okay, so we are looking at a negative correlation between recognition memory, so the accuracy, how often people recognized the words, and their frequency. Now, we know that this comes from a logarithmic, like this was originally logarithmic, right? So let's run the model and then we might transform this back to logarithmic to see what that looks like. So this is the code that I need for the simple linear regression model. And here we have it. Okay, so our t-value explains to us that we have a negative correlation between these two variables. Our p-value tells that this is an extraordinary, like this is very significant. So this is a real effect that we're observing. Mind you, there might be other things that are happening here. So we have a significant result of a negative correlation between recognition memory and word frequency. And we see here that my R squared, which basically tells us what percentage does one variable influence another, is about 1.5%. Okay, so the influence of word frequency on recognition memory is about 1.5%. Next, I'm kind of interested in this, but I want to think about undoing the log 10 untransformation that we did last week, so we'll be retransforming it. Combined, we want frequency, and we want that to be log 10 combined frequency. But we'll call this one log frequency, so it's different. Okay, so now in that data set, I have an additional frequency metric. And what I'm going to do here is take that, oh, let's do the model first, huh? Yeah, I'll do the model first, and then we'll look at the... So now we're dealing with log frequency as opposed to frequency. We can run that model again. And we see we still have a significant negative correlation between the two variables. But in terms of how much influence log frequency has on recognition memory, well, we're up to over 8%. So when it wasn't transformed, when it was the raw counts, we were at about 1.5%. Here we're at over 8% of recognition memory accuracy scores is on account of word frequency. Let's take a look at the chart. I want to see what the transformed data set looks like. Boop, boop. Ka-chow. All right. So this is a better distribution, right? Like this plot tells us a better story as to what's going on here. We still see a negative correlation between these two variables. It is significant. The R squared is much higher when we use the log transform frequency measure. So keep that in mind if you are running your tests. Okay, what I want you to do is I want you to do exactly what I have done here, except I want you to choose your own metric. If you have a significant finding, like I had a significant finding here, p-value was less than 0.05, then let me know. I want to know about it. Teach me something new. It might be new, it might not be. All right, ladies and gentlemen, get to work. I want you to do exactly what I've done here, but with your own metric. All right, have fun.